All right, Ross and Alex,
Hello.
Hello, hello.
how you guys doing?
Doing all
Good.
right. Thanks for having us.
Um, we talked at NAM show, and I've been wanting to get some CNC manufacturers on for some time, and I think you guys are the first. But I'm also curious, was ShopBot, like that name has been around for as long as I think independent luthiers have been thinking about getting CNCs into their shop. How long has ShopBot been a entity? Since the 70s?
No, it's actually the company proper started in the mid 90s.
Yeah.
Uh, our founder, Ted Hall, neuroscientist that taught at Duke University, started tinkering with CNC machines probably in the early to mid 90s. And then the actual company proper started in officially in 96. So we're
Yeah.
in year 30th anniversary this year.
So
And
that's early. Like in terms of like um the space that you're in for you know guys that aren't going to buy a Fidal or something like that. Was ShopBot primarily the first in the space or close to it?
speak to the
Yeah.
that history.
So we were primarily first in the hobbyist and light industrial space. Uh, if you've got 1 minute for a backstory on it,
Yeah.
um, as Ross mentioned, our founder, Ted Hall, who still works with us today, I'm actually skipping out a meeting with him right now. And he started this whole endeavor because he wanted to build a boat, a sailboat, in his spare time as a research scientist. And if anyone here's ever built a boat out of the stitch and glue method, you know that you have to be very exact with all of your cuts, just like you are with veneers. And he thought, man, I wish I had a machine that would plot out the lines that I could cut with a jigsaw. And he says, well, that's silly. I could just have a router do it. And when he started looking around, he found machines that you could buy over in Germany and Slovakia, but they were about 100,000 in the late 80s and early 90s in money then. So and they were as big as a building. So he kind of set out on his own to make his, and he was using stepper motors from printers in his research lab to, dispense various liquids of different viscosities. And he thought, I can make a machine move around. Um, so he never built his boat, but he ended up building quite a few machines and working with boat builders along the way. So over the years, ShopBot has really grown into, the company that we have now, and uh, we've had as many as 48 people. We've had as little as 3 when it started. Um, so it's been fun to watch it evolve over the years.
So you guys have been evolving and the space has been evolving, when I mean in the 90s when it was starting, the internet was not even it was a thing, but it was not, of course what it is today. But like what what in terms of like, like what I guess what I'm saying is to for me to go online and buy linear bearings was not it just was not a thing, and now it is, and everything has moved forward in technology. Uh, what kind of stuff are you guys working on for like what's changed over the years, I guess, in terms of like how how your what bearings you're using and stuff like that?
Yeah, so when this all started, the goal was to have everything built out of a big box store, Lowe's or Home Depot. So they literally started from bearings that you would get from sliding glass doors and right angle track and utility track for electrical work. And it evolved over the years to finding more and more industrial solutions. So now we work with global partners like THK is our bearing manufacturer. Um, we have our beams custom extruded from a company in Ohio, that's THK adjacent. We make all of our steel here in North Carolina. We try to keep as much as possible manufactured in the United States. But in a large part of that, while we're trying to use industrial materials and industrial suppliers, still want to provide this to folks that have or don't have access to big bay doors or big rigging companies. One of our advantages is we're able to get machines in a crate through any ADA style door. And maybe that doesn't answer the question specifically, but bearings are THK. Motors, or if we're going to go into specifics, we use a company called Oriental.
From motors, yeah. And the
But-
spindles are from Italy.
Yeah, they're from a company called HSD.
Yeah, so we source them from the places that are doing those components best. Yeah, it's always evolved over the years. Yeah.
So that thing of being able to get it through doors, I mean, that is, I mean, for a lot of us, without the resources to move large machines, like that's a real thing.
For sure.
And how small do you go? How big do you go, and how small do you go in a machine?
Well, our smallest, I'll speak to our smallest model is the desktop model that starts with a cutting area of 24-inch by 18-inch. The actual footprint is a slightly larger than that, but the spoil board area is that dimension. All the way up through custom sizes. What are some of the largest ones that we've produced?
Some of the largest, like off the shelf, that we could, quote and have out in 4 to 6 weeks is a 6 by 12 foot work area. But we have gone as big as 9 by
Super long.
24 feet. Yeah.
Yeah.
There are companies that make very large sewer covers in Louisiana that have those machines. So very custom, but it is doable. Shipping becomes the logistical point of that.
Yeah, some of the more common large sizes are 4 by 8 and 5 by 10.
Yeah, kind of our bread and butter of.
Yeah, in between sizes like 4 by 4. This pretty close to where we have the Desktop Max is actually like one of the more popular luthier choices because it's just long enough that you can do bass guitar necks and full-size guitar bodies on it, but not too big where you won't be able to fit it in small shop spaces. So whenever we go to NAM or when I'm on socials, I manage the social channels and I'm always reposting what people are putting out there. More often than not, the luthiers in our community are posting about their Macs, their Desktop Macs with the automatic tool changer on it. So
Cool. So
Yeah.
where does the space of routing and milling, where do they wind up converging or diverging? Are your machines routers? Are they mills?
They're technically considered routers. Mills are usually fixed spindles in that the gantries aren't moving around. It's a single column and the table will move in X and Y. The router does all three usually. There are obviously companies that kind of mix and blend those two coordinate systems and differences. But traditionally, routers move on a gantry in X and Y and have a larger work area. They're also the most affordable in terms of cut area versus the costs that you're spending. Where we fall into that is definitely in the routing and soft metals materials. So woods, plastics, we have, aluminum, copper, brass, non-ferrous materials. We mill aluminum here very often. And the desktop is a great machine for that. And I don't want to sound too much like an advertisement, but it's a very stiff machine. It's very compact. It's 1 horsepower, but it's what makes it accessible is you're able to plug it into wall power, normal 15 amp outlet. and you can have a little enclosure around it so things can be self-contained.
We find that a lot of people that get the desktop or the Max, the two desktop sizes, um, doing a lot of inlay work, a lot of tight tolerance, sort of finer work because of that footprint. It's a little bit more suited to that.
Yeah, and thank you for bringing that up. I think one other difference is on large format, on our large format machines, we keep a tolerance of, or we advertise a tolerance of plus or minus 0.005. And on the desktop, it's a plus or minus 2. And so that is perfectly adequate for a lot of inlay work. And whereas there are some mills which can go to a half a thou, which is great and in some cases really needed. But when you have expansion of materials throughout the day,
Yeah.
you know,
A little wiggle room is good.
a little wiggle room is good, and also it's spend money where you need to, but save it where you can.
Yeah. And you know, like a mill is just not ever going to have that kind of footprint, right? Like I'm sure some people do, but or some people can afford a mill with a giant footprint. But so what is the difference between the Max and the regular desktop? I think a lot of it, you know, a lot of the people in the Luth group are like you know, we're all Luthiers, so the desktop ones are probably, you know, what most everybody here is interested in. What's the difference between those two?
Yeah, I can speak to this. The size difference is the main difference. The standard desktop is the smallest 3-axis machine that we produce, while the Max is slightly longer. They generally have the same features. You're just getting a larger footprint for your spoil board, and you can also get an automatic tool changer with the Max model. So that makes that one even more versatile for that automatic tool change. Both of them have removable T-slot decking that if you needed to get lower Z height, you could have a bottom deck. You could also remove partial decking to do 90-degree, joinery. So there's lots of modular aspects to it, but they come fully assembled. So it's not something that you have to, those ones you don't have to put together on site. Is there anything else about that you think is important to know about those two?
No, I think that was a great cover for all of it. May I share my screen?
Yeah, absolutely.
There we go. Close that out. Lovely. So this is just our home page here. We have our 3 different models lined up for the desktops. Can you see this okay?
Yeah.
So as Ross mentioned, we have the desktop to start off with, our smallest and most compact model. All of these are 1 horsepower spindles. Um, so 24 by 18 inch. We might have a little bit of a lag here in our internet between the website and us using our video. But
yeah.
And then we have the Desktop Max, which is double the capacity of that. So instead of 18, we're 36 inches, perfect for necks, as to where you could only get a body done on the desktop, but also great for a lot of small inlay work. In some cases, if somebody's in a production setting, I recommend that they have, and it's a small object, 2 machines, um, and then you can put them side by side. As Ross was speaking to, we have a normal spoil board. We can also remove some of the decking. So this is kind of modular decking that goes on. We can also have it underneath, so we can have up to 9¼ inches of clearance. You still only have 5 inches of Z travel, but it's great if you have jigs or fixtures, and you need that little extra room. We have drive screws on both sides, which allows us to get down into the bottom there.
There is one guitar company, I'm sure most are familiar with, Cower Guitars, that have a desktop model with the 24 by 18 cutting area, and they've developed a jig to actually fit standard electric guitar necks on that smallest model. And they've made all of their necks since 2012 on their ShopBot. So that is possible, but it's much easier on the longer Max model.
I did just want to highlight this machine real quick. If someone is in full production mode, I always recommend the Desktop MAX ATC. We redesigned this a couple years ago, so this can automatically change between 7 tools. It is still a 1 horsepower ATC, and you do have to have air, which I would, if most people, if they have a shop, they're probably going to have an air compressor, and it doesn't use that much. It's maybe about 4 CFM. So, uh, this is a great option if you're changing tool paths constantly all day long. And this one does come with a spindle speed controller, so it automatically changes the RPM of the spindle according to what's in your file. So different woods, different materials, different bits will need different speeds.
Cool. And how many, maybe I missed it. How many tools were you able to put on that?
7.
7.
Yeah.
That's quite a bit.
Yeah.
Do you have like, do you have a hacker community around your tools at all? Like, are there people online that are sharing information on a forum anywhere that like?
Yeah. So traditionally ShopBot was very hacker friendly. It's only been within the past few years that people have moved away from that, but we have a forum called Talk ShopBot Tools.
Mhm.
And then we have a Facebook group that people will post a lot of different modifications. There are folks out there using machines that we made 20, 22 years ago. That are still running, and they've done all sorts of things too. So whether they're welding extra attachments on to make their table longer or doing different motors.
Yeah, it's possible.
Yeah.
In relation to the guitar community, we had a customer who wanted a fret slotting
Oh, that's right.
device. What is the actual DeWalt device that is the attachment? What do you call that
Oh, well,
properly?
it's actually a die grinder. It's an air powered die grinder
Yeah.
that this customer was he wanted a faster runtime. So traditionally we would use a small end mill and go back and forth. And he said, I need to get these done in 1 or 2 passes. So one of our engineers thought it was pretty interesting. He took it on and made this one-off for this customer. And we 3D printed a carbon fiber base to hold this die grinder, and made sure that he had a powerful enough compressor to run it on. And so he could use a very particular slotting wheel to do the fret slots.
Yeah, so that is something that we can do. It's just not something that we put as like the regular accessory, but eventually it could become that. So it's interesting to know that, yeah, every once in a while, if there's a custom feature that we feel like we can test and take on, we'll do that. So that was just an interesting one for faster fret slotting. Now that does end to end. So if you're going to do blind slotting at the ends there, you'll probably want to use a traditional bit so you can stop it before it gets to the end. But
Yeah.
that's just a really nice way to speed it up if you're doing end to end.
So you guys figured out basically how to put a right angle,
Yeah.
on there.
Yeah,
That's
right
pretty
angle
cool.
Yeah. Sounds
Um,
fun.
Still while being able to keep your regular spindle as well.
Yeah.
yeah. And that, like, do you have other attachments? Like, do you do a laser or anything like that on there? Or?
We don't have a laser. And I'd be more than happy to go into specifics of why not. Mostly it's a safety and a fire risk, the smoke in the shop and protecting your eyes. Um, we have had customers put them on afterwards, and they work Pretty well. The one issue with a CNC machine running a laser is the speed. The machines are just built for different things. So while our desktops move what we think are relatively fast, it's not laser printer or laser cutter speeds.
So it is possible.
Yeah.
It's just not the highest recommended method. But yeah, there's a company called JTech that
Yep.
that makes a low watt attachment that is compatible. There's also a laser pointer accessory
Yeah, we do
if you want-
manufacture.
if you want registration and other usage for that.
Yep.
For larger machines, there's a tangential knife cutting device, not necessarily for the smallest model, but
Yeah, the tangential knife is a cool product in that it's great for packaging. Or if you're doing foam pieces for custom cases. We have a company based out of a town called Hillsborough here called Walt Johnson Cases. They make saxophone cases, and they use it for cutting
inserts or whatever the
EVA foam.
Yeah.
It's like the same foam that's in tennis shoes, and they'll mill the profiles out, and then they'll cut out the perimeters, which is neat. It's just like imagine the same in a toothbrush. You've got your oscillating or your vibrating motor, but you've got a knife on it attached that can spin in 360 degrees.
So is the knife being so it's not like is it a drag knife or is the knife actually being controlled in its direction?
The latter. It is. It's got a stepper motor on it, so we can control it 360 degrees,
Wow.
and it's stroking up and down
Yeah.
3 millimeters worth. So it's acting as it's an oscillating saw essentially.
Yeah.
there is a drag knife with attachment as well now that you bring that up, there's a what looks like a 45-degree angle blade attachment that you can put in the spindle, and that I've seen used really well with leather and other fabrics and some light foams.
Yeah, if you have a vacuum table that can hold down with the drag knife, it works really well. Which we offer vacuum tables on all 3 of our machines.
That's a really nice feature to have things get sucked right down to the
Yeah.
through the coil board. Yeah.
So well, while we're on the doohickeys, how many other doohickeys do you have besides the knives and the? Is that
So
it?
many doohickeys.
We have these are a bit more of the smaller items, but there's a company called Widget Works that makes one of the drag knives. They also make like a little plotter pen.
Yeah.
And
the engraving, the diamond.
Oh yeah, the diamond drag.
Yeah, engraving bit. Yeah.
Which is great for non-ferrous metals. And steel too, if it's a nice clear steel.
Yeah.
You can get some really cool etchings or on glass, mirrors.
That's a really fun one. There's a lot of usage for that diamond tip.
Yeah, we have a couple of companies that use it industrially for scribing serial numbers onto nameplates, like chromed nameplates.
Yeah, I'm sure there's a bunch more that we're not thinking of, but those are some of the ones that we see used pretty often.
We have a probe that we sell occasionally for 3D probing. We made this years and years ago, probably 12, 13 years ago at this point, before laser scanners were as common and readily available. Now you can just download an app on your phone. But you can probe the perimeter to get a shape or a DXF, like a profile of the thing that you're making.
Yeah.
And then also do a 3D contour, which it will take a while. But that's the advantage to having a robot do the work instead of you taking measurements.
So it would probe in the Z-axis as well then.
Correct. Yeah, in all 3 axes.
Oh wow! Did you guys write all the software for that too, or?
Yeah, we did. So on 2 subjects to that, going back to the kind of open source hacker community, ShopBot's software is open source. You can download it right from our website, free of charge. We encourage folks to learn the code. It's Visual Basic, in structure, but we also provide kind of a cheat sheet of all the commands. And so over those years, we had a lot of people kind of join the team because they got interested in it early on. This idea of shareware, share the files, and people will start to do things, and we still really kind of push that notion. But we had somebody join the team that ended up writing the software for that probe.
Yeah.
Cool.
There's a guitar body
yeah.
that we probed. There was a Les Paul standard guitar body that somebody had made here before I was here. And I remember Brian had made a little video of doing all the probing on that.
Yeah.
It's pretty neat.
Were you, what was anything done with the probing with the file after that? Was the file used for anything like making another one up?
It was to make a copy of an existing part. Yeah. So it just like with 3D scanning, it was doing it with touch points with the probe. Yeah. But that was before I got here, so I'm not sure what they ended up doing with that, but you can replicate parts that way.
Yeah, we just had a member get a 3D scanner that was it's come a long ways, both in terms of the early ones. When you say the phone, I've been playing with the LiDAR on my phone since I found out it would do it, and it's pretty good for rooms and stuff. For guitar shapes, it's not quite there yet, but this new scanner he's got that this member named Luke has is pretty bonkers. Also, it seems to come with software that cleans up the scan quite a bit too, because it seemed like part of the problem with the early scans was just kind of erroneous noise in the scan. But cool. Anything else you want to take a look at some of the bigger machines in case somebody's got interest in getting a big dog?
I tell you what, how about I'll share my screen one more time and we'll go through them, and then we can run out to the shop and do a quick tour, and you can see the production machine.
Yeah.
It's 3:30 here, so production's probably just wrapping up.
Cool.
So that'll work well.
Yeah. It'll be a little quieter.
James, you got any questions for these fellows?
Yeah, not any specific questions. I'm looking at the pictures and it looks like you put a lot of thought into making it self-contained and compact. You got the VFD on the gantry, and I'm assuming that the sort of solid section at the back has the drivers and controller.
Yeah. So here in this back cover, both for the desktop and the Max and Max ATC, we've got 5 drivers in there. 2 for the X, 1 for the Y, 1 for the Z, and 1 for a rotary axis if you choose to buy that as an accessory. And then it's all kind of self-contained, and you can just take it out with 6 screws if you need to work on it later, or if a driver goes out, or you want to add some accessories.
It's really great. I mean, it's very clean and compact and self-contained.
Thank you. We you know what, this is a really, I don't want to sound boastful, but we're very proud of our desktop. We're happy with the engineering efforts that different team members have put in over the years for it. So it's turned out to be a good product. I'm going to switch over to our gantry tools now. So we have a couple different lineups. You can see this number while it's loading. It's PRS5. That stands for essentially personal robotics system. And this name was coined years ago.
5th generation.
Yeah, and so we're on our 5th generation of our frame, which is the most modular that we've had it. And everything is 7-gauge sheet metal that we have formed and powder coated here in North Carolina, so just about 40 minutes away from us. We have everything that's blue, as you see, is sheet metal that's bent. And then we can build it in 4-foot sections. So this is 1 bay here. This whole table can go together. If it's your first time, I'd recommend 2 days. We also offer a service for technicians to come out and build it. And they can usually get it done about 4 hours. They're really quick. So this is the alpha system. The difference between it and what we call our standard, our starting product is this has closed loop stepper motors, so that if you run into something or take too hard of a cut and you fault a drive, it'll stop the file and notify the operator. The biggest difference is you can tell it has this big silver box in the front. This is a 4x8 version, but they can also come in all different size ranges from a 32-inch gantry to normally a 6-foot gantry. And we also offer these in an ATC as well. But we start with a 2.2 horsepower spindle. And if you've never used one, that is plenty of power for, I'd say, 80% of the stuff that you're doing. We can also offer different things like 12 or 6 or 12-inch rotary indexer. We had mentioned the tangential knife. We have all different types of vacuum hold-down systems. So if you have a single phase or 3-phase capable shop, we can accommodate both of those. Let me pull up our ATC here. So the ATC, we offer this in a 5 horsepower variant. I apologize for the lag. Depending on the width of the machine that a customer purchases, with a 48-inch table, you can fit a full sheet of plywood. It comes standard with 9 tools. So these are called ISO 30 tools versus the desktop, which is ISO 20. It's a little larger mass. The 5 horsepower ATC is great for production. We have 2 here in house that we use almost every day. At least one machine is running every day, if not 2 all at the same time. We have a full vacuum system for it as well. If you have a 60-inch machine, so 5 feet of cutting area and the Y, we can accommodate up to 11 tools. And if you have a 6-foot machine, we can go up to 13. The larger the machine you have, it does, you start to lose just a little bit of precision. So you might go to like 7th tolerance. But some of our smaller ones here, we built this for a sign company in New Jersey with a rotary indexer on the front. So you can do turning work and flat sheet work if you need to.
Hold on, back up to that turning work.
Yeah.
Yeah, that's the rotary indexer. It's something that is a 4th axis.
So that's basically like a lathe hanging off the end of that.
Yeah, like I usually call it the digital lathe, but there's probably better terminology.
Yeah. So unlike a lathe that'll probably spin, say 1,000 or 1,200 RPM, you can take incremental steps with this. So you can machine all of one side of something and then move it over to a different angle and machine another side. Or you can just index it and use it as a lathe. So you could do spindles on stairs and just put in a single profile and do it that way. But the main advantage is being able to take these micro arc steps, every 1/10 of a degree or so, and get some really neat detail in places you wouldn't normally be able to with just a 2-sided machining.
Mm-hmm.
And those come in different sizes too. So that what's that size considered?
This is a 6-inch, so we can have up to 6-inch stock, and we also offer a 12-inch. We have done larger versions in the past. In fact, my first machine that I ever built here was for a company that makes carousels.
Oh, that's right.
Specifically, the wooden horses on carousels, and that was
Quite the
quite a cool
the
company.
Yeah. So yeah, and they come much. You can get a small size that goes on the desktop and the Max as well if you wanted to do small turning as well.
Correct. Yeah. Does anyone have any questions before I switch over to go into the shop?
We'll stop sharing the screen.
Hold on one second.
Okay.
Yeah.
Anybody have any questions? All right, let's go out and take a look at the shop.
Nice.
Great.
All right. Gonna switch over to Alex's phone and we'll do a big loop here.
Is that on the Rotary? Is that like is that just like a regular lathe chuck on that, or?
We offer two variants. We have, so yeah, 3 and 4 jaw chuck, depending on what you need. I'm just going to mute the conference room so we don't get feedback.
You're actually probably going to want to maybe leave audio on that. It seems like you got it. Seems like you got it. Is that a guitar at the end of the table there? What do you got guitars in there?
Oh, yeah, we got a couple of samples. Let me flip this around. Or else do you want to describe a little bit of what here you go.
Thank you. So now I can hear everyone. Yeah, what we're looking at here, I brought out some samples that we've made over the years. This is actually a PRS style body that StuMac actually made this sample for our NAMM show for these past couple of years. I made this Les Paul Junior double cut with the help of some coworkers here. I'm still working on my first complete guitar, so this is just the beginning of my adventure into guitar making. This neck was made by Bob Mizek, if you guys know him from his Luthery and Luthery Academy. So actually, Alex and I ran this a couple of years ago now. His Strat style neck there, and a couple other inlay pieces here. This is by David Mathis in Pilot Mountain, North Carolina, and he does some incredible inlay work. He's worked with Wayne Henderson. A couple other major manufacturers hire him for custom inlay work all the time. He does his work on a desktop machine. And I think the only other like really cool, intricate one that some of you may have seen a video from StuMac about is that ukulele headstock with the koi fish recon stone inlay. And Brock did an amazing job with that project and sent us that sample as well.
We were talking about the diamond drag bit a little while ago, and here we have an example of some powder coated steel.
It's a little hard to see with just the powder coat, but it has a little robot design on a pedal enclosure.
Oh wow, yeah.
Yeah, with like a raw aluminum or galvanized steel, you would see that engraving a little bit clearer. But this was a nice experiment to see if we could get a nice clearer design on powder coat.
We might pass a few examples that we'll pick up along the way.
Yeah.
So Ross, I'm actually going to take a little different tour here. I'm going to go through our
Sure.
office.
Excuse us, sorry, we lost the meeting one moment. Just 1 second.
Just getting it back on the phone. Okay.
All right, we're back. Sorry about that.
Quite all right.
All right, so we're just going to take you through the hallway here as we would introduce people. So here is our founder, Ted Hall. He was the main founder behind ShopBot. Here are a few pictures of prototypes over the years. One of the first examples that got unveiled. This is when he brought it to a woodworking show and people had gotten interested. So it's Friday, so most of the office is cleared out today. But
Hold on. I gotta. I'm not sure. I think we lost him again.
Hey, Ian, why does he have a separate box for conference room and then he's walking around and there's like 2 boxes in there? What's up with that?
There we go.
all right,
Yep. We
there
got.
we go.
We
And
got
we're
2
back
cameras.
now.
There we go.
Yeah.
So did
So
you make all the furniture in there with ShopBots?
No, not these chairs, but this table was.
yeah, so yeah, as Ross said, the table was, and then actually these were made by a customer of ours. Yeah, and he just stopped by recently.
We got bad Wi-Fi in the conference room. Oh, are you there?
Yeah, okay, I think I figured it out.
Are you guys on local Wi-Fi or?
Yeah, I think it was it switching back and forth. So my apologies.
That's all
But
right.
yeah, these were actually made by a shop botter that helped us out a couple of years ago, and they've held up fantastic now. I think they might be about a decade old.
Mhm.
And usually they, all the maple trim starts to yellow, and they've held up very nicely. But these are a few examples of people that have made things over the years, some signs. We've got a few boat models. And here we have some local customers that have made everything from modular furniture, a vehicle manufacturer that does a hybrid bicycle and it's like kind of electric drive chain, some snowboards, and then some playhouses here. So just kind of going through the office, we've got everything from engineering to tech support. We have kind of our lineup of past tools and some projects that have been done on the machines.
Tell me about that zebra. Who made the zebra?
Oh yeah. So talking about the tangential knife here, these are individual pieces of foam that have all been cut out.
Oh, wow.
And so that is the tolerance that you're looking at with the tangential knife because there's no material being removed. It's just slicing through. You get this slip fit, which is really, really nice. So here we've done some painted colors and slipped them in. And here's the contrast of this.
Wow. And that's what's going on with the chest set as well?
No, this is actually called color core. So this is milled HDPE. So this is a piece that is laminated on 2 sides and then milled out, and the reverse of this, which is 1 piece milled on each side as well, but to be the negative.
Wow.
Here's some acrylic for this may be hard to see against the light. There we go.
Which tool produced that?
This is probably a very small end mill, maybe a 20 thou. See, so we're moving over into our production side of the shop here. So we also offer training. So here we have a selection of desktops that folks for training come to use. We do 2 people per station. And we get them up and running from the very basic. You can know as much as being a full-fledged designer using CAD software every day, or have never even seen a computer before. So we encourage folks to have some computer literacy, but we can definitely start from wherever you need to. So we can have up to, go ahead.
Oh, what would be the CAM software that you're using for those classes?
We use a couple different versions. We use VCarve is the main one that we start out with. It is the most affordable and the simplest to get going. But truth be told, it can do 95% of the work that you'll ever need. Stepping up from there is its big brother called Aspire, and it can do some 3D modeling and some complex 3D toolpathing. And then from there, we have companies using Fusion or Rhino for some more complex parametric style modeling.
Really cool. So how if do you have to own a ShopBot to take the class, or can you just buy a
Nope.
seat? Or
You can just buy a seat. It's $650 for 2 days. What is it?
600 for 2 days.
Oh, 600. Pardon me. 600 for 2 days. It starts usually on a Thursday and Friday. We actually have one coming up here next week. We try to do one once a month, depending on how many people are interested. And so we can have up to 10 people. We normally have 8 seats, but we have a machine in the back that we can pull over this way. And to answer your question, no. We have people that are interested in buying a machine or want to try to learn some design or see if it's maybe a way to get their business going. So all in between. We have a lot of teachers that the school might be interested in the ShopBot. So yeah, exactly. They might have one that can come in. So yeah, we try to cater to as many people as we can.
is that happening more? Do you are more like high schools getting CNC in their woodworking classes, or?
Yeah. So education, or the education market, has always been a big part of our inventory and I guess really what we cater to. But I think we've seen a push in the last 5 years, probably actually since COVID, really, people moving back into the trades, especially Gen Z and now, shockingly, Gen Alpha, going more towards working with their hands. So it's really been nice to see people taking an interest in woodworking and keep getting back in the shop.
Very cool.
I'm gonna move you on over here to production. Ross, there's a light switch over in the corner by the computer. If you could go flip that for me. So we prep as much as we can here. So we do all of our electronics. We stock all of our wiring. We make all the pneumatic assemblies. We get all the sheet metal in, bent and powder coated, ready to go. And then we wire up all of our control boxes. So this is a standard box. Do all the motor testing. We run tests and print out stickers to make sure it's past QC. Program all of the controller cards that actually take the data from the computer and turn it into movement. We've got some gentlemen that run the electronics area doing that to spindles. We test every single spindle before it goes out. We run it all the way up to 24,000 RPM. We assemble the wires, the circuit boards. So these are our actually old stock. Well, they're for older machines that we make new parts. So this machine, this would be going in a machine that's probably 13 years old at this point, that we just want to make sure that customers are still able to stay up and running. So we have, boxes and boxes here of VFDs for larger tools and all the parts that we have prepped for the desktops. So this comes out later to a section that you'll see in the shop where we just drop this whole unit in and start to build the machine.
If you had to guess, how many parts would you say you inventory?
How many parts?
Yeah. Are you over a
Oh
million?
man. Gosh, I mean, are we talking about nuts and bolts?
All the way down
and-
to the tiniest screw.
Oh, it's got to be millions. It's, you know, are we also counting all the washers that were lost under these racks?
Probably better.
Yeah. So, you know, sure, I'll say up to 5 million in that case.
Okay.
But this is kind of our R&D area, which I apologize every time I bring anyone out here is constantly a mess, but I think that's a good thing because stuff is getting done. So we have actually one of our employees' machines that he has built and purchased. This is a machine that we offer for the Japanese market, but as well as the American called the Saburuku, which means 3x6 Japanese. We have a Japanese partner called Vild, like build but with a V, and they requested a machine that could accept 2 tatami mats in size. So normal sheet goods of 4x8 are not a common thing to find over there. So you'll find smaller sheet goods. So this is a 6x3 foot platform. Over here we have one of our older machines that we actually just traded out about 2-3 years ago. We're very close to Duke University, and they bought one of the first models of this tool. So we kind of brought back this relic, and it still runs fabulously. Here are a couple of prototypes that we're working on. I'll save some details on this. We might disclose them at a later date.
Uh-oh.
Yeah, some
Corporate
fun new surprises
espionage.
coming out. Say what?
I said corporate espionage. What's going on over there? Right?
I'll let Ross expand on it at a later date. That
Okay.
machine right there.
Oh, sure, yeah.
So we've got our R&D 5 horsepower that we use for making all of our desktop crates. We try to build as much as possible in-house. So all the aluminum we get brought in, we cut to length and prepped. So all the work is done for this week. We cleared everything out, but this is our gantry building station. So all of the steel comes in from our vendors. We build the crates and pack them. And then once that's packed away, we build the gantry. The gantry starts as a raw beam. All the hardware gets put on. It's squared across this device right here. All the hardware is then tightened and torqued to spec. And finally, it's wired up. We try to have the gantry totally knitted and flushed out before it gets put in the.
Can we go back to that a little bit? I saw a bin hanging off the work area. Do you like those bins? Do those go with the machines? Like do you bin up all the parts and then they travel with the gantry and just
No, these are actually just bolted straight to here. So we just put a little carriage bolt.
Oh, okay.
You said you're Duke University. Are you in North Carolina?
We're in Durham, North Carolina.
No, I'm in Garner.
Oh, well, you're right down the street.
I am. Literally.
Yeah, you should come visit.
Yeah, okay. I'm 65 years old. The tech scares me to death. The cost scares me to death. So you're gonna have to do some convincing of why I need one of your.
I think we already have.
Huh?
Especially you're building mandolins, right?
I am.
Well, your repetitive stress injury should scare you to death. Carving a mandolin by hand is like, oh my God.
Yeah, that's true. But
destroy your hands.
it would take me a year to figure out how to even figure out the recipe for inputting all the data and figuring out how to,
go take that class. They got that class for $600.
Well, I'll tell you what, Mark, let's come have lunch one day and then you see how you feel about it.
It's a deal.
So how
All
do
right.
so in that build process, how are you keeping track of like what parts go with what machine and stuff? I guess that's what I thought the bins were doing.
Yeah, so let me go over to a pack list here. Let's figure everything out. So when an order comes through for a machine, it will come through with the spec. So, you can say something, this is for a high school example, and it has all the accessories that'll go with it. And then it will have all of the bill of materials and the documentation. So from every single area, each area gets a pick and pack list. So they'll prep a VFD, a control box, a spindle, etc. And they all get brought out onto this cart eventually. And then we have essentially a roll of parts that are kitted up. So when we come over to this section for the hardware, we use carriage bolts to assemble the machine frame. Carriage bolts are amazing. They are self-registering. They're super, super strong. Single one of these bolts can hold, what was it? It was a shear strength of like 7,000 pounds. This is a grade 8 alloy, so it's what's used in most automotive bolts. And then we'll use a nylon block nut, and you torque it down to 20 foot-pounds. Sorry for I'm being super technical here, but we kit everything up so production can just grab 1 or 2 or 3 or how many we specified for each machine. And you can say it's a 4x4, you're going to get 2 of these. If it's a 4x8, you're getting 3 of them. And everything starts to go in place. We have these little templates here to assemble all the bolts and put them in place for the legs and the upper cross supports. So one of those gets grabbed, zip ties from miscellaneous wires. And then they all start to go into a hardware box along with each piece of steel that goes with the machine. There's a count on it. So every 4x4 gets, 3 cross supports. Every 5x10 machine gets 5 cross supports, and it's all outlined for production.
How long does it take to get a new, if you got to train a new gantry builder up to speed, how long does it take to get them to where they're?
So funny enough, we just transitioned somebody from our desktop area, which we'll go to in a moment, to the gantry area, and he's taken about 2 to 3 days. Now, obviously, this person has worked with electronics before, but we've got a nice little document here that somebody can follow for the first time on how to do all the wiring, how to do all the bracketry work. I wrote this document, and in fact, I need to make a revision for this, but covers all the number of links for your E-chain, how to assemble different parts of the machine. So you can kind of break it down. And the idea is, think of it just like giant Legos. How can we make it as simple as possible? If no one's seen a wrench before, how can we have them build a robot? Let's see. So we're going over to our fabrication area. So that's kind of all assembly. So we have just very simple tools. I say simple in terms of we don't have any special joinery machines, but we've got a table saw and we've got our CNCs. So we'll get a stack of plywood in and some HDPE and various acrylics and polycarbonates. And we do a majority of our cutting on our 5x8 machine right here. We have a 8.9 horsepower vacuum hold down system with 4 different zones, 5 horsepower ATC, and I can show you changing tools right here. So it might be, let me know if it's a little blurry. But we've got a toolbar on the back that will pop up. And then when the tool's been picked up and registered, it will go down. This is more significant, or I guess more helpful for folks that are doing production runs of sheet goods, so cabinet makers, boat builders, people are doing sign work where something needs to come in one side of the shop and out the other. Just like the table saw in your shop is kind of considered the heart of the workshop, this takes place of that, and so you need that flow of material coming along. We've got a few smaller machines over here where we do our plastic work. This is a custom machine that we built years and years ago. We do not offer this for sale, but this is a dual-headed machine where we do special jigs and fixtures. You can see how old it is. You can see the yellowing of this plastic. This is our Desktop MAX ATC. A little dirty. We were just cutting out some furniture miniatures for a video. But these use these tiny little things.
Yeah, I have a quick question. Yeah.
Yes, Glenn.
Yeah, I'm running, Fusion into it's a PRS 10216, which is, I guess, a 4x8 machine. It's in a shared workspace. But one of the biggest challenges I have is the spoil
Everyone
board.
still here okay?
Oh yeah, Alex, we
Give me
actually
a
had
thumbs up if you can hear.
we lost you for a second, but we've got Glenn has a question. Can you hear him?
Can you hear me?
Hello, hello.
May have lost audio.
Your audio came back for just a second. Can you hear us, Alex?
All right. How's that, guys?
Much better. Can you hear us?
Yes, sir. Yeah, sorry about that.
We got a question from Glenn.
Yes, sir.
Yeah, can you hear me? Yeah, I'm running Fusion into it, but it's a PRS 10216. I guess it's it's a 4x8 large scale machine. But the biggest challenge I have, as and I'm almost seeing all the machines there, the MDF spoil board is great for sheet goods, but is there any thoughts or pieces that you have for hold down jigs for when you're doing finer work, like making a neck or guitar a piece that's often double-sided, or is that more in your desktops?
Yeah, that's a great question. So over here, we actually have an HDPE jig. And so HDPE is really good or really bad depending on your climate. If you have a lot of humidity and temperature fluctuation, not the greatest, but the easy thing is it's nice to mill. It mills very cleanly, and you can put in a nice fine gasket. We're using a vacuum here by the company Becker, which is the same manufacturer of our large pumps, and we can get very high pressure, but very low flow rate. So it's good for holding something that won't have any holes that go all the way through it. Much like the jigs that you may see at Rockler, sometimes you can get the little vacuum pucks. It works in the same way, but HDPE phenolic is really nice. It is a more expensive product. Are you familiar with phenolic?
Yeah. My question is more how holding down the piece. I see the machine you have there, has nice teeth and set up for that. But most machines, have an MDF spoil board. I'm just curious, if you have any tips or tricks on how to hold a jig onto MDF, or kind of.
Oh, I understand. So if you're looking to hold the jig onto MDF, what we often do is create a keyway or something that we can mill into here. So we might have a plywood piece that gets sucked down onto that, and then we'll use clamps or maybe a bolt and screw that will then hold that down. In some cases, we've had another vacuum. So if you need to come back and do sheet work later, it can be taken off. And don't be afraid to, I always encourage people to screw in. Here on our newer machines, we now can offer the extrusion that bolts to the cross support, then it can go all the way across the machine if needed. But if you're just working with the MDF, I'd recommend making a fixture on top of it. So plywood and then whatever extra holding piece. But I'd be happy to talk to you one-on-one if you have some questions. I enjoy working in Fusion, so we can work through some models.
That'd be great. And that's what I end up usually doing is making a jig and then mounting that onto the MDF and then working from there so I can repeat. What is the best way to get a hold of you guys? Is that you said there was a talk ShopBot Tools? Is that a forum or a?
It is a forum, but I tell you what, I will put my email for the engineering and the marketing at the end of all this. We'll kind of display it on the screen, and then we can, if anyone has individual questions, we can go from there.
Sounds good. Thanks. I'll get back onto the tour.
Yeah, good. Thank you for the questions. Let's see, so we're almost at the end of our tour here. So we have a couple desktops prepped in the area. We try to build the shelf as often as we can, so if somebody needs a speed order. So we have an older machine that actually came back from a customer. And you can see this is an older VFD. I believe this is a refurb tool.
Actually, we're sometimes getting into some, we're starting to get some refurbs in where we can offer some of our desktop series at a discount, but still have the full warranty. So that's another nice thing to know about.
So standard desktop size, 24 by 18, 1 horsepower spindle, becomes fully assembled. We've got a 3/4 inch thick aluminum frame, and it comes on a pallet that can be disassembled. Over here, we have one of our Desktop MAX ATCs with a vacuum hold down. So customers traditionally use a fine vac. It's a very high power, high quality version of shop vac. I love them. They're very quiet. They're around 66 decibels. In fact, I think the fan to cool the spindle is louder than the vacuum itself. Here we have a few machines in the build process. So you can see the frame itself is the 6061 aluminum that's bolted together in a square. We use M8 bolts with 8mm pins, so they're pinned and bolted together. We have custom extruded aluminum gantry here with THK rails. So we've got two 15mm rails that are holding on our Z. And then we've got a couple of different size or length, stepper motors. So these are NEMA 23 stepper motors on all axes. We've got two on our X driving it, giving us a little over 110 pounds of force for the X axis and about 55 pounds of force for the Y axis. All the cables are ran here in-house, so you don't have to worry about electronics. You just plug and play. And you can see some of the prep area where all this has been done beforehand. All the stepper motors have been pre-assembled, pre-loaded. Everything's been heat shrinked and color coded and ready for production. There's some longer units for the desktop maxes. And finally, towards the end, once everything has been assembled and glued, we run testing and squaring and surfacing routine. So if you ever see a little bit of dirt on the machine, or, well, not dirt, but MDF, really, it's because we've done a squaring routine. We try to clean them off as best we can, but sometimes we might miss a little speck or two. And this is to ensure that we've framed our spindle correctly. We want to make sure that everything's going out square and level. So there are several things to check in that. There's the gantry plates, the gantry itself. The bearings, make sure that they are parallel with each other all the way down, and then make sure the spindle is both square and trammed to the table. If anyone uses boats, also known as your trim. So we can see that show up in the spoil board, see if we have any marks, which this one is flat as can be. There's not a single mark on here. So you guys come to the shop and you meet Chris, thank him. Kudos to Chris for getting this one ready to go. And finally, we'll do it's called a burn-in test. And we kind of crash the gantry very gently against the front of the rails here. And that makes sure everything has been put through a vibration test and make sure nothing's loose. We don't want anything, if we did miss something, we want it to show up here and not shipping. Let's see. We try to prep all the plastic and aluminum parts. We do offer an enclosure for these machines. They mostly get used in small shops and schools. So we'll prep everything on these carts. So when they're ready to build a kit, we can just pull them out, and that way they can be flat packed with the crates and machines. That's pretty much it for the shop tour. Does anyone have any questions?
I do have a question, if you don't mind.
Yes.
I see that you have a couple of those desktop units on roller carts, and frankly, that's a great option to have in a small shop like my own.
Mm-hmm.
Do you have is there any impact when you're doing intricate work, cutting fret slots or inlay? I really, that would be caused by, motion, sitting on a cart and not being anchored to something permanent?
So to answer, yes, if you have a lot of movement, there is a chance for there to be movement in the whole machine if it's on wheels. But on the same carts that we offer, those roller carts are meant that we saw over in the corner are meant for assembly. But the stands that we offer are all equipped with leveling feet. And the casters stay stationary. We've taken them off here for production, but they all get leveled to whatever surface they're on, minimize any vibration.
So that's the preferred way to anchor it somewhere, basically.
Yes, sir. Yeah, I always recommend people using using the feet and then finding true level of the machine using a spirit level.
Thank you.
Really cool. So what's is there anything coming along in CNC technology that we need to know about? Like, is there anything like, are you putting accelerometers on machines like the 3D printer people are doing, or anything crazy coming down the pike?
Yeah, let me tell you what, give me one moment to answer that question. We're gonna head back to the conference room and we'll talk a little bit about what's coming.
Okay.
All right. Can you guys hear us?
Yep.
All right.
Great.
Yes.
So, kind of talking about what's coming forward, is we passed by a machine that we would talk about what's coming, and that is our low horsepower ATC. So, we've got a couple things to cover: one mechanical, one software. For a while now, we've had some requests from folks in the area transitioning from a hobby shop or kind of, beginning to get their business off the ground to light industrial that want a larger platform machine, but don't necessarily have the power requirements of some of our larger um, units. So this blends the 1 horsepower ATC with a large machine. So the same thing that you'd have on a desktop, but you can just plug it into standard wall power, and you can have all the way up to a 5x10 cutting area. You can still cut through sheet goods. You can do aluminum, non-ferrous metals, inlays. You just have the same speed and power and size, but with less power requirements.
So a better price.
Yeah, it's going to be a lower price because we don't have to have the complicated pneumatics that we have for the large spindle. It is, of course, a smaller spindle, and then you have a smaller overhead for a shop as well.
Kind of filling that middle ground between if the max size is just too small for what you need to go with that next size up. But you don't want to go with the alpha that's the flagship, most expensive, need different power requirements. We're filling the gap in the middle with something that should satisfy a lot of in between decisions.
Yeah. So that's one that is a physical product that we're looking to release. We're working super hard on getting all the documentation prepared for it, which is
Quite the undertaking.
that is the largest part of any product release is adequate documentation,
Yeah.
internal and external.
Oh, yeah.
The next thing is actually a software product, and in the world of everything moving to subscription and pay for this, pay for that, we don't we try not to fall into that ethos. We like to just give people something, pay for it once, you have it forever, and really let folks run with it. And so this is a system we've been working on for quite a few years. So I'm going to go ahead and share my screen here.
How long have each of you been with the company?
We actually both started within 2 weeks of each other.
Yeah.
In 2021.
Yeah, so they're coming up on 5
Yeah,
years.
we're coming up on 5 years both in a few months from now. There are some folks here that have been here a long time, and there are also some people who left to do work with their ShopBots as an independent business, and then have returned to ShopBot to work here sometimes 2 or 3 different times.
Yeah, we've got 2 folks that are on their third round.
Yeah. So it becomes quite the connection throughout people's career. If they had a chunk of time here, chances are they may come back around.
So can everyone see my screen?
Yeah.
So if anyone is familiar with running ShopBot, you'll see this is somewhat familiar, but a little different in terms of colorization. So this is called FabMo. FabMo is short for fabrication motion. This is a new control software that we've been building for the past couple of years. And it's really to kind of bring us into the current age of motion control, as well as the idea that we're able to make specific applications for each customer or clientele. So we wanted people to feel familiar here starting off. We have kind of our regular SP3 layout where we can enter in commands, we can use drop-down menus, but we've also got these kind of quick buttons here. So we can go home, X, Y, and Z. We can set the Z0 positions. But
Correct me if I'm wrong, but the 2 main things that we we'll be talking about, in terms of like advantages of this new software. Simplification, making things a little faster, both physically and where you find your menu items.
Yeah.
The machine itself, can you speak to the
Yeah. So
efficiency?
if you have a cut on SB3 that might take you, let's say you're making a sign, right? Or you're doing a 3D carving. If it's taking you an hour in SB3, it's probably going to take you about 45 minutes in FabMo. That's just because the information being relayed to the machine is so much more efficient. It's processing a lot more data a lot quicker, and it's really smoothing out your cut. So you're getting a better cut quality, a faster cut time, and more information being sent to and from the machine. We can also monitor this remotely. So here we're on a local network here in our shop. So I'm on the same Wi-Fi as this machine is. I've hooked it up to a router. Ironically, the router's hooked up to a router. And each individual machine is running an IP address. That means I can have multiple machines running and look at them all at different times. So I can have our machine in production running. At the same time, I have a machine in my dev area running. And so I have a camera on this particular machine, which has seemed to fall. So it's just looking at the floor right now.
But it is out there.
Yeah, but we can just look at up to 2 cameras here and kind of show what's going on. So this is kind of our default app. We can also load a series of jobs in, so we can, run several files in a row for a customer. The biggest thing is probably these custom apps that we have. So we are trying to set up a library of apps that will help customers get up and going. So if you need to surface your table, you have something called the Simple Surfacer. You can input all your bit diameters, the size of the thing that you want to surface, and step over percentage.
These are just taking away a lot of extra steps that used to be involved, or just simplifying and making things go faster, and that's the name of the game.
Yeah, and also introducing, trying to take out some of the tribal knowledge that a company or a person may have to have in a CAM software, a CAD and CAM, to design something. I'm going to pull up a website here called Labs at ShopBot Tools. This may take a second to load. We have a weird instance here lately where internal websites take a minute to come to fruition. Let's see, we'll go back to our apps here. We've got stuff for probing. So if you have a specific work area that needs to be mapped out. So if you look at a 3D printer, it'll probe different parts on the bed and see where it's level and not level. We can apply this to a cut file to make sure that it adequately adjusts the file heights to the cutting surface.
Is
to make
that
sure.
is that new? So you're doing a bed scan on the bed?
It's essentially a bed scan. Yeah.
Is that new? Like,
This is all new. This is not, none of this has been released yet. So you guys are kind of
Okay.
getting insider peek.
well, that's big news, because that's probably a lot of the accuracy right there, right? Like,
That's correct. Yeah.
Yeah.
Um,
So we have some beta.
we have 3 beta users out there. So if anyone has it, we're going to be releasing on a desktop first.
Yeah, the smaller models.
And I'll be transparent with everybody. We have 2 things contingent left. That is spindle speed control and alarm and fault detection on our large machines. Once we can get that implemented, it'll be available on everything.
Yeah, we're very close.
are any plans to have an app so I can start the CNC while I'm at the grocery store? Or
I mean, essentially, can you with your connection you have to be part of? You have to be on the network in order to control.
You have to be on the network of the tool.
Yeah.
So, if you're running on your phone's wireless network, the chance of you getting to connect to the tool remotely is possible, but not recommended.
Okay.
So
But this is still much
So
more.
certainly I can start the machine from the bathroom. That was what you're saying.
absolutely, yeah.
Okay.
And look at the video of it so you know that nothing's going haywire.
Yeah, especially when you have a long cut on or a long 3D raster finishing pass, and you want to say, it's got 40 minutes left. I can go,
Upstairs, make some lunch.
yeah, exactly. Grab a cup of coffee. So here is a repository of some apps that have been getting worked on. We have a couple different things. Actually, let me think of how to start. So when you first build our machines, if you build a large one, there's something called the vacuum plenum that you have to install. And this is a modular app to say, how big is your table? Is it 120 by 60? And then where do these sheets need to get cut in to put in place? Where do these zones need to go? How many zones do I want to have? Do I only want to have 3 or 4?
Yeah, depending on what size parts you need to hold down.
Are you in metric? Are you in standard?
So these, they're basic but very useful. They could be getting more complex, but these are definitely ways to get started without.
So in the old days, you would have had to model that in software or something, or?
Correct.
Yeah.
Yeah, you'd have to lay out your table, and we do provide all those files, and we still will. But this is just a great way to use a UI to click a few buttons and say, this is my size, this is how many zones I want, and it will give you a generic file. Now, if you want to start customizing locations, you're moving into a more advanced knowledge realm there, where you have to take things into your own hands.
But these apps are designed to be very user friendly and very basic in their nature to start out with. This one's really cool. You can actually just push and pull panels and choose the sizes on the side, and you can come up with a cabinet shelf of just about any size very, very quickly without even going through the CAD software. This could be sent right to the machine to cut. So there's just some really fun ways to get started without going too deep into software.
Yeah, so this machine, pardon me. I haven't actually played around with this whole coworker. It just made it a couple weeks ago. But you can take panels and it will do all the joinery for you. So let's see if I can get this correctly.
You just click on another one. Just click on another open area and it should show you another panel.
You've got import JSON up there. Have you messed with AI writing JSON for you for this?
We do quite a lot of that. So we do a lot of macro generation, a lot of the UI that gets done. We have quite a bit of help from Claude.
Yeah, it's very powerful.
So we take a lot of the internal code that we have and either help refine the graphics on it, especially when you're putting something into HTML format or CSS.
Yeah.
And
I was just thinking, like on that import JSON, you could, like a user could tell Claude, I want you're making like a dresser shelf or something there.
This is just a default shape, but you can go into that sidebar and put in dimensions that you want for the just it's almost like SketchUp. But you can see there's a sample. All those pink and pinkish purple lines are the joinery that they automatically generate.
Oh, really cool.
Yeah, this is just a really quick way to get started to make a piece of furniture without much knowledge of.
So you'll never need to go to IKEA again. You'll
Right.
never.
I think so.
I mean, that would be the great part. I think a lot of people talked about that type of concept when printers came out.
Yeah.
It's taken us probably 13, 14 years to get there, but now you can buy a bamboo printer and download anything.
Yeah, well, I saw the top of what looked like a bamboo printer somewhere in one of your
Oh, yeah.
break
Oh
rooms.
yeah,
You
we
guys-
have one in the office. It's lovely. I have one at my house.
Yeah.
Um,
Just a nice tool to have.
which is, if I can be frank, inspired us in ways that it's always good to see what companies outside of the CNC router world are doing, to see where the next generation is expecting the tools to operate with. So it's been cool to play around with that and also just see how plug and play it's been and thinking about how can we help our customers do the same thing that don't have that same type of knowledge that you traditionally have to have.
Oh, absolutely.
We don't have to go through all of them, but
Yeah.
it's just nice to know we're developing a bunch of simple apps that will get
Well-
people started.
I mean, that right there, I mean, yeah, that's it, isn't it? Like, I mean, I went from an Ender 3 to a bamboo printer. And that step, you know, like I don't know that I could have turned uh, you know, a lot of other people onto 3D printing based on the Ender 3, you know, like it was a big ask, but this is certainly bringing it down into like something that people can get their heads around. This is
Yeah.
amazing.
Want to start making some topographic maps, you just choose your region here. You can choose the elevation height. You can, drastically change the height if you want it to be higher. And this, again, this is just something that can bypass the CAD software and go right to cutting. So it's just fun apps to explore when you're first getting started with this. How
Wow,
many
this is
time do you guys I don't know how long you normally go on these
Oh, we
sessions.
can you want to show us a couple more? And we've had you for an hour and a half. I'm more worried about your time than our time.
Mhm.
Yeah.
I can nerd
See.
out on this stuff for quite a bit longer
For
than most
sure, right?
people.
We've got 20 more minutes. How's that?
Okay.
We don't have to go right to 5, but yeah,
You want to ask a couple? Does anybody have any more questions before we
we'd
before we
love
move
to
on?
love some conversation.
I'm just curious about the 2-day course. What kinds of things from a guy who knows nothing about this? I'm fairly techie, but
Sure.
what do you do in 2 days, and what do I get after $650?
Russ, do you want to go or do you want me to?
We both have some good insight on that. For me, I came into ShopBot without CNC knowledge aside from loading and unloading a CNC table at a wood shop.
Perfect.
Yeah, and so the basic training course really takes you from here's how you're going to first start using the software, here's how it connects to the machine, here's a couple different methods of how you're going to hold down material. It's really a step-by-step catered to, in person. The couple of trainers will always walk around and help everybody, so no one's just guessing. Um, it's 2 full days from 9 to 5, but there's breaks. We have you meet everybody at the shop. You get another shop tour. It's an immersive experience. We really want it to be fun, and you get your money's worth, so that when you leave, you have a couple of small projects that you made, and
Okay.
yeah, just to
Cool.
feel confident that you can get up and running once you leave the course.
I get to build a spice rack.
Yeah,
Yeah,
Sure.
you can if you want. We try to have kind of an icebreaker at the beginning of every training
Yeah.
course where people talk about who they are, their background, what they do.
and what they want to accomplish with it.
Exactly. That's probably the most important part is that way we can start to think about pairing folks up either here internally or with other members of the training that may have some experience. So if you want to learn how to do inlay, we could do a sample inlay project, even if it's just putting MDF into MDF, you're starting to build that knowledge base of how to do more complex, more expensive materials.
For sure.
So do any of your machines, for instance, can I carve a mandolin top and carve the inlay on the same machine with just different cutter heads and or whatever it is that I don't even know
Yeah.
what the analogy is.
Yeah, all sorts of different operations can be done on the same machine. You know, a lot of luthiers are making really nice jigs that where you can locate the same exact area every time for a particular operation. It's all exploration and experimentation. Yeah.
The
So
limit. I'm sorry. Go ahead, Mark.
I have a friend of mine who works at a engineering firm near here, and he has all the files for carving tops and backs. So if he wanted to give me those files or whatever, we make a deal, and I could cut tops for him and blah blah blah. His data would just fit into this whole scheme, and I could plug that in and carve a top.
Yeah, so that's kind of the next portion that I was going to go into is there's two levels. There's designing and then there's outputting the files for the machine. So if somebody has already designed it, it sounds like your friend has, making the 3D model that you'll need to machine the top or the back or the neck, and then you'll go in and put it into the design, into the CAM software, that which stands for computer aided machining, and you'll put in the specifications for
How
what
you
type,
want it carved, right?
yeah, what type of bit you're going to use, what is your step over, how fast are you going to go. Those are the intricacies that you will start to learn in the training that we will cover. But
And there's
every
no like
there's not just one
yeah,
recipe.
there's not just one way of doing it. So that's why you use test material first always. And some bits might break if you have it ramping too fast. There's just it just takes some experimentation until you find exactly how you want it to cut. And then it's endlessly repeatable. So once you've found your formula for whatever you're making and you'd like to make multiples, that's the magic that we're getting with CNC here, is the repeatable precision.
Yeah, anyone who's ever done this told me you're going to break bits to
For
start
sure.
with, because it's
Yeah.
just
You're gonna break bits. Mark, we did it's not up yet, but we did an interview with Matthew Dunkelberger, who's a F5 builder out of Ohio, I think. And he's pretty tooled up. The F5 mandolin is it's a bit of a project because like on a carved top instrument, you've got to, build a fixture to hold it indexed, to make your
Yep.
outside cut, and then flip it over and know exactly where it is in space to make your
It's-
inside
yeah.
cut.
It's
So
probably one
there's-
of the most complicated projects. My friend is my friend does this. He's got a homemade CNC, but he's not the healthiest guy, so he's not real active anymore, but he's got that all figured out. So
Yeah, it can be done, and it's that's one of the things about the Luth Group is we've got resources to help you figure it out if
yeah,
it's
cool.
something you're interested in. But it is probably if you want to build one mandolin, it's probably faster to build one mandolin with a a file and a sharpened hoe blade than it is to. But if you want to build 10,
Sure.
or if
Yeah,
you want to
Ian,
build 100, then
that's a great example. Thank you for using that analogy, because there are many things that we do here in the shop that we'll just make one of. And if it's more complicated than using a chop saw and a table saw and then a couple of hand planes and chisels,
We'll recommend to do it the other way.
yeah, then we'll say, okay, we should use the CNC. But it's also just feels nice to work with your hand. I'm not trying to say don't use a CNC, but it's also nice just to use a chisel
There's a place
sometimes.
for both, and also I don't believe that there's any, when it comes to instruments, you cannot 100% do everything on a CNC machine. You have there's from designing before you even cut anything on a machine to the all the handwork that comes afterwards with light sanding, finish work, setup, all the things that you are all doing now. CNC is going to, there's like two main methods that we always say. You're either doing the grunt work of like quickly roughing out the main shapes of things that you're going to keep using, Or if you'd like to have the machine run much longer, you can get it to a really fine point, but it just depends. Do you want to make a lot of something or one of something? How much time do you have to use it? And so there's a lot of variables, but
The difficult part and the advantage with CNC is these kind of areas right here, where when you do the scroll work
for sure.
and the binding channel, it's really time consuming and hard to get that right. And I still can't get it right after I've only built 15 of them, 14, 15, but so the CNC, if they can cut those binding channels out and cut all these angles and get it right, it's worth its weight in gold.
Yeah.
It's super hard to get that right and do it every time, the same way. So anyway.
Yeah.
Thanks.
For sure. We appreciate
Of course. Thank you. Anyone else? Do you have any other questions?
So
I'm super excited you guys are working on apps and stuff and getting interesting things like probing the bed and all that stuff going on. The bambooification of CNCs, I think, is especially for the consumer. The border, small manufacturer blurred into like hobbyist manufacturer is I think a super interesting space and got a lot of potential for growth. I mean, I've been using the 3D printer for a while now, and I still have yet to take a cut on a CNC. It does feel pretty intimidating to figure out cam. It seems like the barrier into cam feels bigger than the barrier into like a slicer.
Ian, you don't do CNC, Ian?
I've never done it. No.
As teched out as you are, I thought for sure you were like
well,
aged, bearded CNC master.
My shop's in my basement too, so I don't even have a door to take my to take a CNC through. They do say you can get it through a door, but I don't have a garage door to get it through.
Well, if my uncle in New Jersey can get all of his woodworking equipment down 2 flights of stairs into his windowless basement,
Yeah.
Oh my God.
I think we can help you get
we can get the CNC down there.
Yeah.
All right. Well, I'm keen on trying it. It's definitely definitely on the to-do list to get done at some point. But
come on down, Ian. We'll take the class.
Yeah.
All right.
We'll do some training for sure.
Well, everybody can we unmute and thank Alex and Ross for hanging out with us and
Thank you.
showing us the cool stuff.
Thank you. That was great.
Yeah.
Thank you
very
Everyone
much.
showing up. If you got just 1 second, I'll post in our chat here.
The email address.
Yeah, our email addresses. Unfortunately, I think these go away once we log off.
We can.
I'll post them. I'll make sure they come up with
Okay,
the.
we'll just send them to you, Ian. Then.
Yeah. They'll be appended to the video. We record everything, so.
Yeah, and keep an eye on StuMax YouTube content because they have some videos in production with a ShopBot that they have there in their video studio where they're taking you through all sorts of CNC processes. So stay tuned with all the StuMax content.
All right, guys.
Sounds good. Thanks.
Have a good rest of your day.
Thanks.
Cool.
Appreciate
Thanks,
it.
you too. Bye-bye.
Take care.
All right.